Thank you. It's good to have you here. It's not exactly something exciting at this age because it could be last time we see you. So anyway, at conferences these days, I feel a little bit, I start feeling a little bit out of place because I see people far younger than me. But on the other hand, there was a time in which I was the youngest in this kind of rooms. That was over 30 years ago, but that's it. That's life. So this talk is about modular monoliths and or versus microservices, avoiding microdisservices. My career, 30 years old career, has been split in two parts, before and after the pandemics. So I was essentially a speaker, a consultant, maybe top-notch consultant, but occasionally joining companies for short amount of times, looking into things, saying, okay, I said, giving my recipes, and then go out of the office, leaving people in the company dealing with the real business. This has changed after the pandemic. So since 2020, I took the position, full-time position, as the CTO, head of development at a company called Creonet, which is the company active in sport tech that deals with the platforms, the software platforms behind operations in professional tennis and professional paddle. So our software systems take care of calculating the rankings, the world rankings of paddle, to ensure that world rankings of tennis, I mean ATP, the finals in Italy this week, WTA, ITF, those rankings receive data from our systems. We run the data points from the court up to Bet365, all the way through. In addition, our company has other interesting products, a ticketing platform, a credential and access control platform, live on-site content, graphics, TV production, etc. This is my full-time job. On parallel, I'm invested in a company that does health tech, that is developing things in the healthcare system. This is to say that since 2020, I've been deeply involved in building stuff. The curious thing is that all this stuff that runs interesting businesses for patients and sport fanatics is 99% built on plain ASP.NET full stack applications on Azure, and using an architecture that we could call modular monoliths. So probably the simplest ever thing. The funny thing is that not that many months ago in spring, we had a chance to go to Redmond, the Microsoft headquarters, talk to some big shots, the same big shots I started my career with. I started side by side with Scott Guthrie, the Microsoft VP, Executive Vice President. I went to him, he put in touch with people to consider doing a case study. Wow, the World Tennis is running on Azure using ASP.NET, that's great. So when we explained a little bit the underlying structure of the systems, they said, not that cool. It's so simple, so we're not sure we want to make a case study out of it. It's too trivial, yet it works. So the point of this talk is that the root of all software evil, and I take the pride to say that because of my gray hair, is those managers, those engineering VPs who says, well, microservices, if it's good for Amazon, if it's good for Netflix, if it's good for Google, it should be good for us too. We are much smaller. So the people, you, the people, The young people, the youngsters in this beautiful industry are so excited to do some new thing. Okay, let's do microservices. In the end, what we do is jargon-first architecture. Before we look into the features, before we look into the real business that the software has to solve, the real problems and the real workflows that the software has to address, we focus on the architecture. We have to use microservices without pinpointing if it's correct, appropriate, and which are hidden costs. So, SOA, service-oriented architecture. I was live and kicking and in a way involved in the Amazon move to SOA in 2003, 2004. Not that I've ever worked for Amazon, but I was in touch, personal confidence with a couple of the people who moved from Microsoft to Amazon to implement the vision of Jeff Bezos to split the original monolith of Amazon following the service-oriented architecture. It was the same time in which Microsoft were starting pushing out Windows Communication Foundation services. So the vision of components running independently and communicating over replaceable protocols. So I'm a fan of services. It's the micro that leaves me a little bit confused. So, if you take the jargon-first architecture slogan, it's yes, in the end, it's SOA, but with a lot of unnecessary infrastructure, or just ad hoc SOA and then microservices. It's a lot of naming, and that's it. So nothing is really new. It's about splitting functions and having those functions, one after the next, coded in the most effective way for the business we are trying to address. Now, let's take the definition. If you ask ChatGPT, once I would have said if you Google for, but if you GPT for microservices, this is more or less the wording that you get. An architectural style that revolves around the development of independent, modular services, each focused on a distinct function. Okay, what is function? How big is the function, or how small is the function? Nobody says that. So if you go further and ask GPT, can you tell me more about the size of the function in this context? It tells you that there is no evidence of what could be the right size of the function. It is as large, or it is as small as the minimum to support a business capability, which means nothing. It's too generic. It's obvious, but it's generic. So again, what is the difference between service in the SOA sense, web service, and what is the significance of microservices? But anyway, put down this way, nobody would argue that this is an absolute piece of truth. It's a clever idea. It's moving from monolithic blocks to distributed, broken down pieces of functions that work independently and modularly. This is an important advance, an important progress, a bringer of great changes in the way we think and build applications. The mankind will progress. Let's for a moment try to compare this to the invention of the wheel. That was another great moment for the mankind. The invention of the wheel was a groundbreaking invention capable of guaranteeing efficiency and achievement of greater results. However, invention of the wheel, but also shortly after, the realization that without roads, it would have been problematic to move heavy loads from place to place. So the wheel is great, but the wheel works great if we have roads. So this talk is not against microservices, but this talk is against jargon-first architecture. So which problem are we trying to solve? Are we just trying, when we approach a project or when we apply for a job, trying to deliver some functional production system, or are we just trying to play with an application written in a particular style? So what is the mean and what is the end? For me, the end is building software, building stuff. The architecture, the architectural style is a means. Amazon. History says that Amazon started from a monolith and moved to a SOA architecture in around 2004. Now, let's take the pros of microservices. Any conferences, 5 years at least onward, that has talks with microservices in it, you find a speaker that tells you, okay, microservices are great because they are not like legacy monoliths that are tightly coupled, they then don't scale and are problematic to extend. Okay, let's take the pluses. I summarize the pluses to 3. More agile development cycles, increased potential for scalability, fault tolerance. Only 3, yes, because usually you have 10 or 5 or 8 or 9, but they are just redundancy. If you squeeze out the substance, it's probably these 3. But the point is that each of these 3 pluses have a significant number of red flags, not necessarily drawbacks, but aspects you should be very well aware before you judge the goodness of an architecture for a problem. The issue is that managers, executives stop here. Developers and architects have to deal with this. And when this list grows longer, and it will grow long in just a few seconds, you have not the power to go back and change the architecture. So you have to stick this way and keep on adding complexity over complexity, infrastructure over infrastructure, lines over lines, to come to an end. Let's take the first one, more agile development cycles. The dream of parallel development, the dream of the code that, like 9 women can produce a baby in a month. That's the dream, right? So more agile development cycles means that you have several teams that work on, in parallel, on different small pieces of code independent from one another. But what about cross-cutting concerns? What about logging? What about security? I'm not saying that it's impossible to log or impossible to have security. I'm not saying that. But it's not straightforward. It requires forethought to be implemented. It's a problem to deal with, and you must be aware of that. You cannot take it for granted. But more, the orchestration of complex tasks, the more you reduce the pieces at work, the more you engineer the more you have to put connections between the small things. Think of a body, a human body. We have a brain, we have a heart, we have veins, we have muscles, microservices. But there is a lot of connections inside the body. It's orchestration of complex tasks. We have a TV ad these days, the commercial in Italy, of a bank, in which to express how cool are their service, they make the comparison between the muscles involved with breathing. It's 36 different muscles involved every breath we take. Orchestration of complex tasks. They want to say that they do complex tasks at a click, essentially. So the ad makes even sense from their perspective. But that's it. And to orchestrate complex tasks, which are the business tasks, you need additional infrastructure. Go back to the definition. Yeah, but the size of the function is not the size of a method of a class. It's the size of a business function. Business function is not writing a record on a database. Business function is a complex task. And to have a service that takes care of a business task, it's not that micro. And usually in companies, in real world business, complex tasks are the orchestration of other tasks. So the need of orchestration is unavoidable. Now let's talk scalability. Clearly, an application that is built by a number of independently deployable components, sure, has inevitably, rightly, an increased potential for scalability. Now, how do we get scalability? Suppose we have an architecture deployed as microservices. How do we scale it up? Typically, we go horizontally. We just increase the number. If a microservice is suffering for performance, we just increase more copies of it, like lanes in a supermarket, checkout lane. No? You just add more cashiers if there's a crowd of people. Now, how do you achieve horizontal scalability? Via statelessness. That's it. If the component is stateless, gets input data, produces output without storing anything inside, it's okay. You can have as many copies of it as you want. But it's just, so the point is statelessness. Statelessness has been invented, and it's been a concept in software since decades. So every piece of software should be stateless. In, out, just a map function. F of X, X in, epsilon, Y out. That's it. But going horizontal, duplicating microservices instead of simply thinking of statelessness, involves the use of auto-scaling and the use of tools, Kubernetes, Docker Swarm, because these tools exist, extra tools, just to detect in some way when is a good time to spin up more instances instead of waiting you to do that manually. But also, more microservices, again, monitoring their state. Debugging issues means going to node to node to node to node to find out what could have gone wrong. Interdependence of microservices. No. It's a fairy tale that microservices are independent. No. It's the code. They are independent as a class. A C# class can be independent. No. Period. No way. It's a fairy tale. Out of this, okay, you can also get scalability using the vertical approach, just more resources, more CPU, more database power. But it's a cost that you raise, and it's temporary. fault tolerance. Now, the system I put most of my time on these days is the software, the platform through which supervisors in tennis, specifically the women's circuit, run their operations. So sometimes, but by contract, we have to be 24/7 in charge and pretty reactive if something goes wrong. It's not acceptable for sponsors that tournament in China, tournament in South America, no matter the relevance, as long as these tournaments are part of the international circuit, the supervisor there should be able to push out the order of play every single day, many times a day if needed. No way, that has to happen, period. And they expect the graphics is perfect, but they don't want to create that manually via Excels. So we have HTML that generates the perfect output, but sometimes they put too large or too horizontal or too vertical logo. Sometimes there's a player that has a name, we put no more than 40 characters and it's 45. So sometimes there are missing data. So there might be issues. Not often, but it happens frequently. So if the issue has to be solved with a new push, a new fix and a deploy, we do that because we are in pressure. Maybe we don't run all regression tests. So we fix something and break something else. It happens. Not frequently, but it happens. And it's part of the business, part of the deal. We are very aware of that. So sometimes it happens that the order of play feature is broken. But if you have a microservice architecture, the order of play is broken, the rest of the application works. The rest, in a monolith, the rest of the application works. It's just the order of play. Sometimes the order of play for a tournament that pushes out an error. The application is up running. So the fault tolerance is achievable primarily with microservices. Looks to me another fairy tale. The point is that if you have a microservice application and say the order of play service is separate from the rest, fixing that only requires you to redeploy that small piece, not the entire application. That's the difference. It's only that. Furthermore, in a microservice architecture, you might want to have a circuit breaker to isolate any other microservice, to check if it's available or not. In a monolith, an exception handler could be enough. Gets an error, yeah, you display. Instead of something has gone wrong, you just put the message, the service is temporarily unavailable, try later. Same story. And you don't need a circuit breaker. A network failure, so the code is inaccessible because of network issues, is the same. The same for microservices and for monoliths. So there are, to cut a long story short, a number of gray areas around the pluses of microservices. The root of everything, in my opinion, is the switch from an in-memory communication between running code to an RPC, a remote procedure call, in which two distinct processes communicate instead of doing that in process in memory. This has at least 3 more blocks of issues. Service coordination. We can summarize in operational overhead, because microservices are not really independent. They are interconnected by business rules, and the need of orchestrating their behavior to achieve business tasks. This requires some gateway, essentially, or you can take the choreography approach, which means that every microservice tries to connect to its own peers, usually using a synchronization tool, typically a message bus. Doable, but yeah, I mean, it's not like making a call. Cross-cutting concerns. Every machine, according to the laws of microservices, is responsible for its own stuff. So every logging is on the physical machine. But if the physical machine is being used in a complex task, that information should be exposed and should be related to the task. So you need a correlation ID. And it's your problem, or the problem of the tool you use to track back all the related steps across a variety of microservices. Distributed transactions. The smaller is the action, the more likely is that two more steps across multiple services should be coordinated and treated in a sort of atomic way. Distributed transactions. We know 2PC, 3PC protocols for dealing with that. And it's unavoidable in a microservice scenario. Now, if you turn micro to macro, so you enlarge the size of the constituent block, you have more chances to incorporate in the larger block some of the actions that will take place now in a single process context instead of going across multiple processes. Also, the help of the use of the fact that it's acceptable from a business perspective, having eventual consistency. At some point, the data you wrote will show up in reading. That's what it means. If this is acceptable, this will definitely mitigate the impact of dealing with distributed transactions in a microservice scenario. Yet another alternative is the saga pattern, using a bus in which events are published and listeners react, so that you don't have an atomic transaction, but the transaction is split across a number of messages, and each handler deals with that for the part that affects its behavior. But again, it's a complete shift of programming paradigm. But my favorite is data management. Now, when you have a microservice architecture, a shared single database is an option, but is considered an anti-pattern. I lost the count of the articles, conference talks that I heard. Don't do that. Each microservice has its own database. Okay, if you have a shared database, it means that you have an entire data set fully constrained and structured at the root, and integrity preserved by default. In a database per service, each service can choose the best data storage technology. It's the ego or it's the business, doesn't matter. But sure, you can choose the storage you like, but it's yours and only yours. Is the data entirely yours? Let me give you an example, practical. Now, in our architecture, in our monolith, we have a single database, okay? But periodically, we reconsider if we are close to the point in which our modular monolith should be split into service, more distributed architecture. The only candidate we have identified to be the first piece of the monolith that could be taken out is the part that deals with players. So imagine we have a single database, relational database with player information with a number of endpoints. So this is a microservice. This is a service that has a number of actions. Create a new player. These are real, okay, endpoints. So taken with a specific look at the processes in professional tennis. So creation of a new player is an action on its own. Renaming the player is something that happens frequently. Because the player, especially women players, get married or divorced, or they just want to change the first name to make fans happier using their nickname. The Coco Golf is one of the latest examples that I'm working on. Updating personal data, bio, typically. The name of the coach, things like that. Change of activity status, retired, inactive, injured, and then more financial-oriented features like the annual consent to blah, 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 security, whatever, and membership things. Now, according to the microservices laws, we have a service with 6 endpoints. No, but each endpoint represents a business capability, so we should break this into 6 smaller microservices. And each should have its own database. Okay, I wrote this slide myself, and I said, this is stupid. It's not stupid. It's well, not because it's me, but it's a great example. Because now, let's try to be serious about this. You have a new player microservice with its own database. This database will contain all players and IDs as well as they are created, as soon as they are created. Then the rename player microservice will contain only the renames. So for each player identified by ID, you can have the list free. You have the list of renames in his career. And same, all the history of changes in his bio, the history of activity status. And sometimes a player moves from inactive to active again, from injured to active. And then the records of membership, the record of consent, she released. Great. Oh, you have a lot more information in this way to deal with. First, do you really need this level of detail? Yes or no? It depends. But the problem you surely have is this. Now, try select start from players. This is a nightmare now. That's why you need GraphQL, which is yet another layer of complexity on top of everything. That's why they created the GraphQL. To move from this to a stupid query like select start from players, where ID. So, database per service, pros and cons. So we see that if we go for database per service, all services are independent from data perspective. There is a clear ownership of data. Changes to the schema don't affect other services, freedom of development, technology diversity. But on the other end, each service has direct access only to its own data. Resort to other services API. So it must expose its own API for others to call and can access other services data only via API. Network latency grows and accumulates for every single stupid select start from player. But combine data from multiple services, a join, a group by, GraphQL, and tools on top of GraphQL, and the need of a circuit breaker. Now, if you take a shared database, the first benefit, no distributed transactions, easy join and group operation, no data duplication, unless it's under control. We do have some data duplication. For example, in the match, we bring in the tennis systems, we bring for each player not just the ID, but also we duplicate a few properties: name, last name, ranking. Why? Because we keep track that that match was played having the name recognized at the time, and we keep track of the ranking the player had at the time. So it's still duplication that has its own costs to keep it updated in case of a rename, but delivers business relevant information. Now, on the downside of a shared database, unclear ownership of data. Yes, agreed. Changes to the database schema may hit multiple services. Yes. Services are not autonomous. Yes, but services are never autonomous business-wise. And the changes of schema are relevant to any piece of the application regardless. Unclear ownership of data, it's true. Database is single point of failure. Okay, I'm not a DevOps manager, but I've been told that there are quite a few services in Azure and AWS, backup, automatic backup, to reduce zero time and and to avoid that any database becomes a single point of failure. So this is not a case. So approaching the end, there are gray areas, and this is a fact. Now, no matter the gray areas, do microservices fit in your specific business scenario? Now, a microservice architecture, so the breakdown is problematic, and there are millions of articles that have magic recipes for that, when you have a monolith to start with, because you know which are the functions. You have a monolith to look at. You see what the existing application does, and you realize that with microservices, you should achieve the same, probably better, but the same. But if you start a greenfield project, we use microservices here, that's the decision made, and you know nearly nothing, you have to study the business domain. It's a leap in the dark. I ran into a conversation on LinkedIn recently in which I read about that. One of the concerns of the writer was that we are realizing that using microservices blindly on a greenfield project, we are back to big upfront design. We have to plan everything in advance because we don't know. We are stopping in the dark, realizing what is relevant, what is not, what is a function, what is an aggregate of functions. We have no guidance whatsoever. And we realize that if the breakdown is not even close to ideal, we are going to run into bigger troubles in terms of costs and in terms of development. What is the real application growth potential? Do you really need all the scalability that potentially a microservice application unlocks? And what is the team's ability to manage distributed development? Do you have people in your company only used to virtual machines? Do you have good DevOps? Do you have people used to work remotely, used to work and organizing the job themselves? So there are a number of points to be considered to determine whether microservices, no matter the applicability to the business scenario, can have in your company. So let's try to outline a strategy for new projects, more or less what I've done 3 years ago when I got this job, and the first gig was set up the operations for the season 2021 of women's tennis. We started in summer. because of the COVID, the project that was originally planned over 9 months stretched to 4. We want to have an application that can be developed without too much overlapping of functions, as much as possible in parallel, that allows to be fixed and improved, can be scaled if scalability becomes a problem, good performance, possibly low cost and low resources. So the strategy I feel warmly to suggest is start with a well-done monolith. Grow the monolith. Following the business needs. Now, if at some point, and at some point it may take years, the monolith gets unwieldy, then consider migrating to a more distributed architecture. But the point that I never seen so much emphasized is that from this to this, or from even to this, if this is modular, the move is nearly free and can be reverted. The key is logical, something that I call logical decomposition. A little bit of history. In the early 2000s, Microsoft released Windows Communication Foundation, the framework specifically designed to facilitate the implementation of SOA principles. It was a huge project, inspired tons of books, articles, conference talks. At some point, a friend of mine, software legend for WCF, came up with a bold idea. Should we turn every application class into a WCF service? It was a provocation. It was not serious about that. But we are now to that point. And if we try to take this every class as a service approach, every function as a microservice, one step further, we start from the business domain, the abstract business domain. We logically decompose it into business functions. I use the term microscopic service to indicate a logical function, but as atomic as it should be, and how much atomic, what is the dimension of the atom is up to you, is up to the architect, to the chief architect. So you decide when to stop the breakdown, but you end up with a finite number of atoms, which represents your business capabilities to be turned into code. So you have the logical decomposition. Okay. Now, it's a matter of how you deploy them. So each of these are autonomous, atomic and autonomous. You just decide how to aggregate them when you deploy. If you choose blocks like this, you have a microservices style deployment. If you put them into a single block, you have a monolithic, modular monolithic deployment. So the analysis is purely logical. You can use domain-driven design, typically. The remaining is infrastructure. And obviously, if you have this, you can go to this, and you can go to this. If any of this is deployed individually, you have a classic microservice architecture with all the problems of the costs, and whether serverless maybe is an option. Going microservices, in the end, is a mere infrastructure decision. Higher level, you have a decomposed system. You can deploy as microservice. You can deploy as SOA, modular monolith, or server. It all starts from the logical decomposition. And if I have to give you a suggestion on how to approach that, domain-driven design, ubiquitous language, bounded context, context maps are the points, the aspects to look into. It's it's how you permute. It's about the number of permutations. It's the number of partitions of the finite set of logical functions. How you aggregate them for deployment. That's it. A few words on serverless computing. The server is not on you. So this is the fundamental point of serverless. The platform you use allocates resources and scales for you and builds for actual execution. Now, for a serverless platform to do its job, granularity is a must. So it can only work with the atoms you deliver, the functions you deliver. So each function in a serverless environment is a microscopic logical service. The problem with serverless computing is vendor lock-in, at least for many companies. You can go serverless easily. It's a clear concept, but you bind yourself to Lambdas, to Azure Functions, to Google Cloud Functions. A less vendor lock-in option is Apache OpenWhisk, former IBM project, that is cloud agnostic and enables deployment across multiple cloud providers. OpenWhisk is open source, but there is recently released a product, a platform that commercializes OpenWhisk and also have several, as an IDE, a development environment for deploying functions, okay, using a number of programming languages. Okay, now to finish off the presentation, which is pretty much time, just quickly, in 2020, we had the call, me and a few people working with me had the call from this company. We would like to hire you to build the operations platform, the new operation platforms for women's tennis. And we started dreaming of a web front end, a mobile front end, an API gateway, a list of functions. We identified already possible candidates to become microservices. The calendar, the setup, the team, schedule, results, starts messaging. The calendar and setup could share the database. Teams has its own database, and so forth. And then, the live updater, the mobile app running on cores, pushing data to refresh the system. Data takers, media companies and betting companies, to receive data, and the beautiful message brokers in the middle. Okay, it's late August when I got the call. Mid-September when we had the kickoff meeting. 3rd of January, the first tournament live, and the platform that should have been able by then to at least enable partly automated, partly manually operations. We then start, yes, what about if we go and realize that at most we're gonna have 10 concurrent users? Okay? So scalability, probably is not going to be an issue. More, tables are read and written at most every few seconds, because we realized that the most common action was scoring of a point. Now, a point is scored in a match every 40 seconds. Usually live feeds are set to 40 seconds, 40 seconds. Maybe a few matches at the same time. This could be 10. We calculated 10, 15 seconds at most. not much work to put on a serious architecture. So we started with an ASP.NET server rendered Razor front end. The API gateway became just the controllers. The application layer, following the patterns, layered architecture from DDD, in which we had exactly the same blocks that we identified as microservices. So the application layer, which is the orchestration layer, so controllers receive the call. Every endpoint here makes a call to one of these entries for an end-to-end orchestration of the task that involves calling repositories to go to database, read and write stuff. But any of those is conceptually, logically independent and modular. Single database. The live updater, the mobile app, writes to an endpoint, expose one more block here, which updates the database. And the live updater does its own things, talking to data takers. This has become a completely separate deployment with two teams, completely different, working. Now, the integration test between the work of these two teams occurred over the Christmas day of 2020, and it took, because it was Christmas, 15, 20 minutes. Okay, I'm pushing the button, okay, I got the data, once, twice, three, okay, that's it. What could go wrong? And nothing went wrong. On the 3rd of January, we started. We went like, it was a crazy effort, but we did it. And it would have been impossible for, and no matter you are Accenture, no matter you are any big Microsoft, no. We did it because we knew very well the business. We knew exactly what to do in each of these blocks. And we chose the simplest yet effective architecture. Now it's 3 years of production. The front end and the gateway been vastly extended and improved. But we are years away from even considering, for the sole purpose of this application, to break it up into components. Okay, this is a monolith. Now, look at the dream architecture and the production architecture. They are comparable. So, if I switch this, it's not problematic to go from this to that, or I can just cut a line here, and I have one gateway and a microservice. I can cut this vertically, and I add a message broker for synchronization, or just go with plain API calls, and I'm done. Of course, the moment I decided to break it down, there's a bit of work. It's free in the sense that you don't have to kill yourself to have the job done. Still good engineering work to be done, but it's doable. Absolutely doable. And yes, this is one block. So you are against services, no? Dino, you are against services. You don't like, you want to live in a dinosaur world in which everything happens under your feet. But the turns ops, this module, is what I presented and expanded. It's only one small part of the galaxy of the IT that our company has. It's a much more complicated web of different applications. All of them are entirely separate. Each of these white blocks has its own stack, its own team. So overall, we can call the entire IT that backs up professional tennis for the part that has been assigned to our company, call this a microservice architecture, but every place is a monolith. So a microservice made of monolith. It's SOA. It's just a service-oriented application. Yeah. The key lies in functional decomposition. I have to give you summarize a quote for the talk is, the key lies in functional decomposition. Once you achieve that, microservices become simply an infrastructure decision, and you are free to make it or not make it, and make it the way you feel is better for you. Thank you very much for your time.